Okay, so now that in the last couple of videos we've used Ddply on the prostitutes dataset to split it up by year, take the mean of each year, and then get out a whole new data frame with our means of how many prostitutes there are for each year, we're going to now go and graph that data. So I am going to run through what I did in the last video just one more time because it can be a little difficult to get an initial grasp of. So we took our original data frame, prostitutes, split it up by year, and for every year, we took the mean of the number of prostitutes. And if you remember, originally there were 12 different values for each year because we had one for each month. But now we split it up into a new data frame where each year only has one row and one number, which is the mean of all the numbers for that year. So our original graph before we used the Ddply function to minimize the data frame would have looked like this. I would have had a couple hundred points. And it was a little difficult to see what each one was. All right, let me just make the points a little smaller, and then we'll be able to see it a little bit better. But this isn't the best. Really, we want just 1 point for each year, and that's what we've done with the Ddply code. We now have a data frame that will be able to make this exact graph, but with only 1 point per year that's representative of that year in its entirety, instead of 12 points. So our new graph, I'm using our average pro data. The new column, pro's mean, is the mean of each year, and then the year on the x-axis. And when I run this, we now, instead of 12 points, have only 1 point per year that's representative of that year. And this graph is so much better because it doesn't have all this redundant data on it. We're not really looking at the variation for each individual year. We're looking at the trend over time. So we don't need 12 points for each year. We only need one that's representative of that year. Now, though in this graph we are looking at the trend over years instead of between months for each year, we have eliminated a lot of data from the graph. We've eliminated the range of numbers for each year. So one way of keeping in all that data without keeping in all 12 of those points is to insert error bars. And to get these error bars, what I'm going to find is the standard deviation of the data for each year. In case you're not familiar with standard deviation, it's the average amount that all those 12 points stray from the mean. So it's kind of the average of the average in a way. What it's doing is, say, let's just look at 1830 for example. This graph shows that the mean number for each of those 12 points, the mean of each of those 12 points is about 3,000. But the standard deviation will tell me that the average distance from this 3,000 that all those other points are is maybe 100. So in that case, I'd want an error bar that goes plus or minus 100 from 3,000. So I'd want a line going up to 3,100 and a line going down to 2,900. And that represents kind of the range of values that this point is trying to represent. So when I run this, it's going to make a new column called ProsSD, and it's going to have the standard deviation for each of those columns. And if we look at this, we've now got the year, the mean of all the numbers for that year, and the standard deviation. Now, when we go to actually graph this, it's not as easy as just saying, all right, I want an error bar with the standard deviation. What we're going to need to do is, it's just another add-on, so it's not that difficult. We're going to add geom error bar, and then the aesthetics, we're going to need a ymin and a ymax. So that's the upper limit and the lower limit of the line for each point. So the easiest way of going about it is saying I want the upper limit of that bar to be the mean plus the standard deviation, and I want the lower limit to be the mean minus the standard deviation. And that'll represent the range of numbers that each of these mean points is trying to represent. And width equals 1 just represents how thick I want the line. And I'll go over this whole code just really quickly as well. So we've got our new data frame with the standard deviations. We've got the y-axis as the means, x is the year. It's a scatter plot, so we want geom point with size being 3.5 and the color being blue. And we're actually going to make it a line graph as well, just for kicks kind of. So we'll add on geom line. We're going to add a title and a y-axis label. We don't need to change the x-axis label because it's just year. And then we're going to change the x-axis limits to be going from 1810 to 1855. And then adding on those error bars. So running this, we now have error bars on each of these points that more accurately represents the range of data for each year. And this is really useful to know because when you're looking at the trend here, we can see, all right, these points pretty accurately represent the trend here. But as we go here, this point might not as accurately represent the numbers within its year as this one does, because we can see the standard deviation is very, very close to the mean. So this did not have that big of a range within the 12 months. But this one, as we can see, had a huge range and the points were more all over the place. So that's useful to know when we're looking at the graph. It gives your viewer a more accurate representation of what your data actually is, without having too many points so that it's confusing. Now, just for fun, I'm going to show you a couple more ways of modifying your graphs, just because I didn't really include everything in my basic videos on how to do scatter plots or bar graphs or whatever. So I'm going to try to be mixing in different ways of graphing into these higher level videos, just because it's fun and it's nice to know kind of what's out there, what's in your toolkit to use. So here I've made each point text instead of a point. So here, instead of blue dots, it's going to have the year in place of them. And it's actually going to have a little point there anyway, just to show you exactly where it is. But the way I've done this is within the aesthetics parentheses in the ggplot base code, I've included a label. So that's just telling it what the text is going to be on the graph itself. I've said the labels are going to be average pro win year, because I want each of those text bits on the graph to be the years. I'm also going to have a point in there just to show the exact location, a title, a y-axis label, and then this is where I tell it that I want text on my graph. It's an add-on called geom_text, and then I'm going to limit my x-axis. So what this looks like is instead of points, I've got the numbers on the graph itself. So instead of just a point for 1830, it's actually going to say 1830 and also have a point there. So that can be kind of fun. I can also make the text change size in relation to the number graph on the y-axis. So here I've got the same thing where I've added labels when average pro is year. But within the geom_text code, I've added a size, and the size equals the prostitute mean. So that's the size equaling the number, and it's going to scale that in relation to what the value is. So you can see it starts off really, really small, and then the text gets larger and larger, which is kind of fun. Not really the most useful here because the numbers overlap each other a lot, but when you have a graph with fewer points on it, this could be fun to do. And the last thing I'm going to go over here is how to just add random bits of text to your graph. So not text mapped to any variable or anything like that. Just text, say if you want, instead of putting the title up at the top of the graph, maybe you want to put the title down here, just on the graph itself. So this is one way of doing it. I'm going to graph this. I've just kind of thrown this text on there just to show you an example. It's within the geom_text box. So as you might see, you can use geom_text for a couple different things. You can use it for both mapping text to a variable, in this case points, so we put the years on the points, or just putting text on your graph somewhere. So here we've added geom_text. We've said data equals null, so we're saying we're not actually mapping it to any data, we just want there to be text. We're telling it the x and y coordinates of where we want the text to be. So I've said I want it centered at x equals 1845, so about here, and y equals 2000, so I want it on this line. And then I've angled it. You don't have to angle it. If you just leave this out, it'll just put it straight horizontal. The label tells me what I want it to say, and then the size tells me the size of the font. So we've gone over a whole lot in this video. We've recapped Ddply and what exactly it does, and then we've gone on to do some pretty cool graphing with the new data. And we've also learned how to put error bars on our graph for standard deviations. In our next video, we'll be moving on to another super useful function called melt.